All right, we've come all this way in fractions just to get back to addition and subtraction, where math all started. But I mentioned earlier in this chapter that addition and subtraction of fraction can get a little bit tricky sometimes. So we'll get into that now. So if we look at this example here, we know the multiplication is very straightforward. You just multiply across. It'd be 1 times 1 and 2 times 2. But addition, you can't do that. You can't say 1 plus 1 is 2 and 2 plus 2 is 4. That would give us 2/4, and that would simplify down to 1/2. And 1/2 cannot be the answer to 1/2 plus 1/2. So that's not right. And you probably already know that 2 1/2 is 1. We could also say 1/2 plus 1/2 is the same thing as saying 2 times 1/2, which we know how to do that. That would just be 2/2. And you can also just add the numerators. You probably know that already. But let's kind of show a few things over here. So let's do, say, 3/5 plus 2/5. Well, like the last section, this is just 3 1/5. So we have 1/5, 1/5, 1/5. We have like a pile of 1/5s, right? And here we're going to add 2 more 1/5s, 1/5, 1/5. We'll just add those together, so then we combine them, and we have 1, 2, 3, 4, 5. 5 1/5, or 5/5. And then another way to look at it is if you remember the distributive property, and real quick side note, let's start thinking about the equal sign a little bit differently than maybe you have in the past. So you might have been thinking of the equal sign as basically where you put the answer. So if you have 3 plus 4, you might think of equals this as, you know, the problem, and this here would be the answer, right? This is the problem, this is the answer, and they're separated by the equal sign. But really, this is just showing equality. It's just showing that this side is the same value of this side. It'd be the same thing if you said 7 equals 3 plus 4, right? Because this side is 7 and this side is 7, so that means both sides are equal. Just like if you did A equals 6 is the same thing as 6 equals A, and so on. So we'll start thinking of these as just the same. Both sides are the same, not so much as you start here and then you get here. Because in this case, we're actually going to be starting here and then going the other direction, which is why I brought that up. So this problem here, this looks exactly the same as this right here, right? Maybe not, it might not look the same to you, but remember, fractions are just division. This is the same thing as saying 1 divided by 2 plus 1 divided by 2. And now it looks like this. So if you remember the distributive property for division, we could have division on this right side of the parentheses, but it would not work if it was on the left side. So we cannot factor out this 1, because then it would end up being 1 divided by 2 plus 2. And that doesn't work, right? We can't distribute that division. But we can distribute out the 2. So we can say 1 plus 1 divided by 2. Right, and we can distribute that. So that would be 1 divided by 2 plus 1 divided by 2, which is what we want. Okay, so then if we do our parentheses first, then we have 2 divided by 2. We know that is 1. So that way works also. So with all that out of the way, let's jump into the first problem. So again, we have 3/7, and we add 2/7. That's going to give us 5/7. Or if we had 3 divided by 7 plus 2 divided by 7, and we factor out the 7, then we have 3 plus 2 divided by 7, which will give us 5 divided by 7. And so 5 over 7. And same thing here, 7 plus 9 would be 16 over 10. Always be looking to see if you can simplify fractions. So 16 over 10, if you divide both by 2, or you can say 16 is the same thing as saying 8 times 2. 10 is the same thing as saying 5 times 2. And we can cancel out those 2's. And we have 8 over 5. All right. So now subtraction. So 17/18, and then you're going to take away 5 of those 18ths. So you're going to be left with 12 of those 18ths. And same thing, you can use the distributive property for this one also. So if you have 17 divided by 18 minus 5 divided by 18, same thing as saying 17 minus 5 divided by 18. And that will give you 17 minus 5 is 12 divided by 18. And that's where we were right here. But we can simplify this down. We can say 12/18 is the same thing as saying 6 over 9. But we're not done yet because we can divide both by 3. So this would be 2 over 3. And that's simplified. Okay, negative 29/24 plus 23/24. So sometimes you might get confused when you have a negative number, then you're adding. So if it makes it easier for you, remember that addition is commutative. So you can just swap the order of these. So let's go ahead and change the order of these, and we'll say 23 over 24. Right, and it's commutative over addition, so we're swapping the order of addition, so that the addition doesn't go away. So remember that it's still plus, but this is a negative number, right? So it has to stay a negative number. You can't forget about the negative sign. 29 over 24. Okay, but you know that adding a negative is the same thing as subtraction. So this is going to be the same thing as saying 23 over 24 minus 29 over 24. You don't have to do this step if you want to just do the problem here like the way it is. That's totally fine. If it's easier for you to think about in this form, then that works too. It's both, you'll get the same answer either way. All right, so if we do it this way, well, 23 minus 29, I think that's going to be a negative number. And that makes sense because if we're at negative 29 on the number line and we move to the right 23 times, we're still going to be to the left of 0. We're not going to make it back to 0. So let's see what it's going to be. So we know it's going to be a negative. Well, if we take away 23, then we'd be back to 0. Then we'd have 6 more left over to take away. So 6 over 24. And don't forget the negative sign. All right, well, we need to simplify this. We could divide both by 2, but we should see that 24 is a multiple of 6. So we can just divide both by 6. So don't forget the negative sign. Divide 6 by 6, you get 1. 24 divided by 6 would be 4. So negative 1/4. All right, so 1/3 plus 2/9. We've only been adding with common denominators. We haven't done anything like this. And I don't know how to do this. So if you ever come across a problem that you don't know how to do, see if there's a way to convert it to a problem that you do know how to do. And we know how to add if they're the same denominators. And we also know how to make fractions have the same denominator. We know a couple different ways to do that. This one's pretty easy because we have 3, we want to make it a 9. Well, we can't just turn it into a 9. We can't just say, now it's 1/9, right? That wouldn't be the same fraction. 1/3 and 1/9 are not the same value. So we can't change the value of the fraction, but we can multiply by 1, right? Because 1/3 times 1 is 1/3. And we know 9 over 9 would be 1. But also in this case, 3 over 3 would be 1. I'm guessing you saw that. So times 3 over 3, that would get us the same denominator. So then that would be 3 over 9 plus 2 over 9. Okay, now we know how to do this. That's going to be 5 over 9. Okay, so then this next one, 1/2 minus 3/8. Well, same thing. 1/2 can be converted. We can just do times 4 times 4. So that would be 4 over 8 minus 3 over 8. And now that's easy. That's going to be 1 over 8. All right, so for this one, how do we make these the same denominator? I can't make this one 4. I can't make this one 3. Well, We can do the same trick we did in the last section and just multiply each by each other's denominator. So we can multiply this by 4 over 4 and this one by 3 over 3. Let's see what that gives us. So that's going to be 4 over 12 plus 3 over 12. All right, that seems to work out. And that's going to be 7 over 12. All right. So then this next one, well, I don't want to multiply 1400 over 1400 and then 24 times 900 and 24 times 1400. That seems like a pain. Well, this can be simplified. We know we can just cancel out the zeros. If there's zeros on, so if it was something like 906, you cannot, don't try to cancel out zeros in the middle, can't do that. Or if it was like 960, we can't cancel out both of these zeros, but we can cancel out one of them by dividing by 10. But in this case, it ends in 2 zeros, so we can divide by 100 and cancel out those zeros. That's nice and easy. What else do we have? Oh, we can simplify this one. Looks like those are both multiples of 3. So that would be 15 divided by 3 would be 5. 24 divided by 3 would be 8. And we're left with 9 over 14. Still not great, but let's go ahead and just give this a shot. So let's try multiplying by 14 over 14. And this one we can do times 8 over 8. And that will give us, let's see, 5 times 14, that would be 50 plus 20 would be 70. 14 times 8 would be 80 plus 32 would be 112. And that would be minus, we're subtracting here. Well, 9 times 8 would be 72. And we already know that 14 times 8 is 112. We did that already. Okay, so 70 minus 72 is going to give us negative 2 over 112. And that's going to, well, they're both even, so we can cut that in half. So that's going to be 1 over half of 112 would be 56. 1 over 56. Well, if we simplify down to 56, wait a second. If we had 5/8 and 9/14, well, those are both divisors of 56. 56 is a multiple of 8 and 14. So could we have just used 56 as our common denominator instead of 112? Let's see. So if we had 5/8 minus 9/14. And let's see if we can get to 56. So 8 times 7 is 56. And 14 times 4, I believe, is 56. Yep. 40 plus 16. So that would give us 35 over 56 minus 9 times 4 is 36 over 56. And that would give us negative 1 over 56. Well, okay. Those are easier numbers to work with. So if you can spot those common denominators, then it makes the problem a little bit easier than trying to multiply these big numbers. So that works. All right, so negative 2/3 plus 6. All right, adding a whole number to a fraction. We haven't done that yet, and I don't know how to do that. But what do I know how to do? Well, I know that like something like 4 over 2, that would simplify down to 2 over 1, right? And that's just 2. So could we go the other way around? So 6 would be the same thing as 6 over 1. So that would be, so 6 over 1. We could also say like 12 over 2. That would still be 6, right? Well, how about, we need a denominator of 3. So how about multiplying the numerator and denominator by 3? So times 3 over 3. Well, that would give us 18 over 3. I think that would work. So let's do negative 2/3 plus 18 over 3. And again, if it helps you to swap the order of these, we can do 18 over 3 plus negative 2/3. Adding and negation is the same thing as subtraction. So 18 over 3 minus 2 over 3 is going to give us 16 over 3. Let's see, 16 is not a multiple of 3, and 3 is prime, so I think that is simplified already. All right. Make sure I got the right answer here. 16 over 3. Yep, okay. So in this last one here, let's see here. We have 3 numbers here. Interesting. So we have to find a common denominator for all 3. So what are the multiples of 5? 5, 10, 15, 20. So 20 would be a common denominator for these two. We could do that first. That's one way of doing it. Or do we find a common denominator for everything? Well, I guess we have to start somewhere, right? And maybe we'll just start right here. So let's do 6. Let's multiply these both by 4 times 4, and this times 5 over 5. This will give us 24 over 20 minus 45 over 20. Right, and that will give us, let's see, 24 minus 45 would be negative 21 over 20. And so we still have our plus 7, 6 we need to deal with. 7 over 6. Okay, so what would be a common multiple of 20 and 6? So let's see. Multiples of 20 are 20, 40, 60. There we go. So let's do, this is going to be times 3 over 3. So it'll be negative 63 over 60 plus, this is just times 10, 10 over 10, 70 over 60. All right, and again, if you want to swap the order of this, you can. So it's going to end up being 70 over 60 minus 63 over 60. You can also think of it as if you're at negative 63, so 63 to the left of the number line, and you're going to add 70 to it. Well, it takes 63 to get back to 0, and then you're going to have 7 more. So it's going to be 7 over 60. And that's your answer. 7 is a prime, and 60 is not a multiple of 7. So that's already simplified. Okay, so another way to do that real quick, though, while I'm here, is we could have found a common multiple of all 3 from the start, which would have been 60. We can see that 60 is going to be a common multiple, and made that, so 6 over 5 would have become 72 over 60 minus 135 over 60 plus 70 over 60. So that's what our problem would have become if we just found a common multiple of all 3 to begin with. And then, let's see, so 72 plus 70 is going to be 142 minus the 135 is Yeah, 142 minus 135 would be 7 over 60. So we get the same answer. All right. Was there a video here? Oh, there should be a video here. I didn't put the little image here, but there's a video in this description. You can go and check that out. All right. So Megan put 3/4 cup sugar in an empty bowl. When she's not looking, her son takes a half a cup of sugar from the bowl. When Megan notices some of the sugar is being removed, she adds another 2/3 cup. All right, so if you start with 3/4, then what happens? When she's not looking, her son takes a half a cup. So takes away a half a cup. When Megan notices that some sugar has been removed, she adds 2/3 cup. So she adds 2/3. How much sugar is now in the bowl? Okay, so we can do this a couple different ways. We can do this one step at a time. We can do 3/4 minus 2/4 would give us 1/4 plus 2/3. We can do it that way, or we can just find a common denominator from the start. And this one is actually pretty simple because we know our multiples of 4 is going to be 4, which is not a multiple of 3, and then 8, which is not a multiple of 3, and then 12, which is a multiple of 3 and is a multiple of 2. So that seems to work out. So let's have a denominator of 12. So 12 minus something over 12 plus something over 12. All right, well, how do you get this one to 12? It would be times 3 over 3, so that'd be 9 over 12. And this would be times 6 over 6, so that would be 6 over 12. This would be times 4 over 4, so this would be 8 over 12. 8 over 12. Okay, so 9 minus 6 is 3, plus 8 is 11. 11/12. 11/12 what? So with word problems, let's see what we're actually talking about and if that makes sense. Does it actually answer the question? How much sugar is now in the bowl? So if we had 3/4 of a cup and we took away half a cup, and we added 2/3 of a cup, then what we're left with is 11/12 of a cup. Okay, so Jake spends a fifth of his year-end bonus on a television and a third of the bonus on a computer. After these two purchases, he has $735 of his bonus remaining. In this problem, we determine what Jake's bonus was. Okay, what total fraction of Jake's bonus did he spend? Okay, well, if we want to get the total fraction, we have to add together these two fractions, right? So let's do 1/5 plus 1/3. Well, let's make a common denominator. So let's say it's times 3 over 3 and times 5 over 5. That becomes 3 over 15 plus 5 over 15 equals 8 over 15. So that's the answer to this part here, 8 over 15. Okay, what fraction of Jake's bonus remains? Okay, well, if we know that the whole is going to be 1, right? Or 1 second, let me... Yeah, so it started with a whole bonus, which would have been 15 out of 15. That would be all of the 15s, right? How many 15ths are there in a whole? There's 15 15ths in a whole. So we started it out with 15 over 15, and you took away 8 of those 15s. So then he's left with 7 of those 15ths. So 7 15ths remains. Okay, what was the amount of Jake's bonus? All right, so let's see if we can come up with a problem here. So he had $735, and he spent. Oh, okay, so that's how much he has left. So 735 is equal to, is means equal, right? Is equal to 7/15 of his bonus, right? Because 7/15 is what is left of his bonus. We don't know what his bonus is yet, but we know that 735 is 7/15. 7/15 of that bonus. Of means times. That doesn't really look like a very good 7. Here we go. Of means times. So of his bonus. Okay. So then what's the bonus? Well, we want to kind of go backwards from this multiplication problem so we can do division. We did that in our multiplication and division section. If you don't remember that, go refresh your memory in that section. But to get to what B is, so B is going to be equal to 735 divided by, use division to undo multiplication, divided by 7/15. And division is the same thing as multiplying the reciprocal. So B is equal to 735 times 15/7. Okay, but let's see if we can simplify this a little bit. So we know multiplication, we can just say 735 times 15/7. You might notice though, so 7 of course is divisible by 7. 35 is divisible by 7. So 735 is also going to be divisible by 7. So let's go ahead and break this out and say this is going to be 735/7 times 15. All right, well, it's going to go into 735 100 times to give us 700, and then leave us with 35, and then another 5 would give us the 35 left. So there's going to be 105. So it's going to be equal to, let me go over here a little bit, make some room. It's going to be 105 times 15. And let's see, 100 times 15 would be 1,500 plus another 505s would be 1,575 if you were to multiply that out. And that would be what? Again, if you go back to the word problem and think about what the question is asking you, what was the amount of Jake's bonus? So it'd be $1,575. And does that make sense? So we know that once he spent 7/15 of the bonus, he had 735 left. So you know that his bonus has to be more than 735 because he used 700. He used 7/15 of his bonus already, which means it has to be more than 735. So if you got a number lower than 735, you know that that can't be right. So you're looking for a number that is higher than 735, and we did get that. So 1575 seems like a reasonable, good answer. All right, so what integer is closest to 87/88 plus 24/23? Well, we see that 87/88 is pretty close to 1. We see that 24/23 is pretty close to 1. So 1 plus 1, I think we've been doing that for a long time now. That's going to be equal to 2. And that's it. We ended off with an easy one. All right, so as you can see, it can get a little bit tricky for adding and subtracting, but hopefully it's not too bad. So go ahead and try some more practice, and then we'll get to the next lesson. See you next time.